Okay, good morning. Welcome to
FamilyMath406a.
FamilyMath406a. So yesterday we talked about this modified Sierpinski carpet from Matt Parker's video. And there were two ways of thinking about it. So first we started with 4 squares. So what was the area?
The area was 4.
4. Then we took out the middle, and we chopped each of the squares into 3.
9. We chop it into 9.
Sorry, the sides. So we got 9 squares, and then we took out the middle third. And what happened to the area of the whole thing when we did this?
It decreased by. We got, I think it was like 4 times 8 ninths was the area.
Okay, the new area was 4 times 8 ninths. Then why did we get this multiplication?
Because you have 8 ninths area left over in here. Times 4, because it's the same in each square.
Okay. And what was the next step that we did?
The next step is we divided each of these small squares into 25 pieces.
Okay, which meant we divided the sides into how much?
5 pieces.
5. So we divided each side into 5. 1, 2, 3, 4. So that's 1, 2, 3, 4, 5. And we took out the middle of that. And what did that mean happened?
Then you took out, so you took out 32 25ths. 32, but, so you took out, like if you just look at one of these squares and you chop them into 25 pieces.
Yep.
You take out one of the 25 pieces.
Okay, good.
So you're left with 24 25ths. And then times 8. Or because you have 8 of these squares. But this side length is not 1 here.
Okay. So first, when we take it out of 1 square, what's the ratio of the area that we have at that point?
Well, we have 24 25ths.
24 25ths. So if we're going to look at it in the multiplying way, we would just multiply the whole thing by 24 over 25. Because that's how much we're taking out, and we're doing the same thing to every square.
Yeah.
Right? So that's why we can think of this multiplication process. But you're right, there was also a subtraction way to think about it.
Yeah.
So we had to figure out how much we were subtracting from what we had, which was 4 times 8 ninths. And how many total dots did we take away at this stage?
It was 8 dots in this thing.
Okay, and how many were in the whole thing?
32.
32. And so then we just have to figure out how big those dots were.
Well,
So initially, this was 1. So initially our 4 squares each had side length of 1.
and so if you chop it into 3, so this is 1/3
Yep.
here. And you're chopping that side length into 5 pieces. So this is 1/15 the original side length.
Yep,
And so this would be 1/225th.
very good. So the square has area 1 over 225 that we're taking away at this stage.
Yep.
And then we take away 32 of them. At the next step, we're going to multiply, we're going to chop up into how many of these small pieces?
Each of the small pieces will get chopped up into 7ths.
7ths. So how big is each one going to be? What's
Well,
15 times 7?
15 times 7. 105.
Okay, good. 105. Can you see why it's 105? 15
Oh.
times 7?
15 times 2 is 30. And then times 3, that would be 15 times 6 is 90.
Uh-huh.
And then plus 15 is 105.
Very good. Very good. And we're going to have to take a bunch of those 105 squares away. I don't know what 105 squared, but that's all right. But the question is, I wonder how many they're going to be.
Well, there would be. Well, you could just you could multiply by 48 over 49.
Okay, why?
Because in each of the little squares, you're chopping it up into 49 pieces,
Aha.
and you're leaving 48 behind.
Yeah, so it gets a little harder to count, just a tiny bit harder to count. But this pattern of multiplying actually stays pretty easy. Okay?
It's 1 less than the square over the square.
And then this magically, and you dot 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 it all the way out, and it's 48 over 49, etc. somehow converges to pi. So that's what we talked about yesterday. And
Yeah.
today we're going to go to 3 dimensions.
Okay.
Alright.